All right, so we are going to go over these review questions from chapter 16 about random variables. And this scenario is asking about this person commuting to work, and it gives a probability model for the number of red lights that she's going to hit on her way to work. Okay? Now, what I'm first going to think here is that my random variable x is going to be the number of lights. So the number of red lights she hits on her way to work. We're going to do this again? Great. Okay? Now, you should see here that this is only about 1 day commuting. Just 1 day. So when I find the expected value for that 1 day, I'm going to take each of the possible number of lights that she could hit, so 0 through 5, and multiply them by the likelihood that she will get stuck at that many lights. Now, I know some of you use the calculator, but do you see all this work that I'm showing? What do I expect to see on tomorrow's quiz? The work. Yes, really. Uh-oh, I'm going to run out of room. Sad. Okay. Okay, now, if you don't want to type in all these numbers and you just want to use your list 1 and list 2, then go there now, but after you do the work. So we have the expected value for the number of lights that she's going to get stuck behind for 1 day is, when's this? Excellent. Okay, so are there any questions on how to find the expected value for 1 day? Okay, but the scenario says for an entire week. So that's 5 days that she's going into work. Okay? So I know some of you probably did this very quickly, but I really want you to think of it as like this. The expected value for 1 day plus a 2nd day plus a 3rd day plus a 4th day plus a 5th day. All right, so what you're going to do is you're going to take 2.25 and add it together 5 times. Now, you learned in elementary school that repeated addition is just multiplication. So you were okay if you multiplied 5 times 2.25. And got, when's this? You had it. What is it, Lenses? 0.25? Wences, what is it? You're good. Okay, so that is actually the answer. 11.25 lights. For an entire week, that's how many we expect her to get stopped at. Yes? I mean, it depends on how the mood I'm in, right? If I'm really upset with you personally, then yeah, maybe I'll take points off. Probably not. I'm really focusing on the fact I want your brain to realize is that they're separate, independent, random variable events, right? If she gets stuck at 3 red lights on Monday, that has no impact for how many red lights on Tuesday. So that's why I list them like that. Okay? Now, the standard deviation. To find the standard deviation for just 1 day, this is where you're going to take your values from the table, the number of possible lights you could get stopped at, like 0, minus the expected value. And then what do I have to put here? Square it times the probability that it could happen. And again, do I expect to see this work? Yes, I do. Even if you're not going to type it in. Yes. Good question. The reason is because I want to first find the standard deviation from 1 day. So for 1 day, and then we'll go from there. Almost there. Last one. What's that one? Times 0.05. Okay, so I apologize. It's kind of hard to see. But all of it is there. Okay, so when you use the calculator, what was the standard deviation for just 1 day of her going into work? What was 1 day?
I don't know.
Too long. Did you use the calculator?
Yeah, I did, and I kept on putting them, and then it just didn't let me.
No, did you use the calculator to do like the list 1 and list 2?
Oh.
So what I would do is I write all the work, but then I put list 1 and list 2 is already in there. 1.26? Anyone confirm 1.26? Nice.
I did
All right.
not get that, but I added that.
Okay. Catherine had a good question or statement. She said she did not get 1.26 because what is Catherine getting when she types all this in? What's that called?
Variance.
That's the variance. Good job, Saul. So you've got squared lights. So you've got to take the square root of that number to get the lights.
So if we did a list, it's already.
Exactly. I think it was the fourth one says S of X. That's the standard deviation of it. That's already given the standard deviation. Jarvis? Absolutely. Should we do it together?
Yes.
Great. All right. Unfortunately, I cannot show the viewers at home. And I have sad news, guys. Last night, I had 9 subscribers that no longer started subscribing to me. Or were no longer subscribed. Yeah. I got an email from YouTube this morning that said, you may have noticed that your subscribers has gone down. I was like, I did. And it's because they closed, exactly. They closed accounts. So I lost 9 subscribers. And that's like 10% of my subscribers. Okay. So what you're going to do, Jarvis, is you're going to first, and everyone listening at home, you're going to first turn your calculator on. Then you're going to hit data. Hit the button for data. Now, list 1, you're going to type in, I know it's listed in the table horizontally, but you're going to type it in vertically in these lists. So 0, enter, 1, enter, 2, enter, until you get to 5, enter. So yes, I think you said this, Catherine. It's actually, there's 6 values there. Yeah. Okay? Now, in list 2 is where I'm going to type in the probabilities. And make sure the order matters here. 0.05, 0.25, 0.35.
So list in list 2.
L1, L2, yes. L2 is where, it doesn't matter, because you're going to tell the calculator which one is which, Daisy, but I think it just makes sense to put the probabilities second. Okay, so make sure you hit enter at the last one, all of them, but the last one, some students forget to hit enter, and so it doesn't put it in. All right, now you're going to go back to that data, but you want to go second data, which is statistics. So second data, which is stats, and you're going to do 1 variable statistics, because we only have 1 random variable. Remember, that random variable is the number of red lights that she's going to be stuck at on 1 day of going to work. Yes, not today. All right, so 1 variable, hit enter. No, so I'm just sorry. I was here. I'm at the stats screen, so I hit enter for 1 var stats, which is 1 variable stat. Now, data. My data's in L1, so that's all good. But the FRQ, the frequency, is not equal, so I don't want to leave it where it is. I go over so that it's blinking on L2 and make sure you hit enter on L2. Okay? So I'm telling the calculator, list 1 has my possible values, list 2 has the likelihood that they will happen. And then you hit enter, or calc. Now you'll see, do you see number 2? FRQ is frequency, and that should be L2 if you're following what I'm doing, list 2. You should see X bar, which we never use X bar, but that's the expected value or the mean or mu, which you see it's 2.25. And then if you go to number 4, you get the number that Charlize got, 1.26 lights. Okay, how are we doing? Everyone okay? No, Leslie, what's wrong? You don't know what's wrong. What did you get?
I don't even remember what I did.
Well, let's go back to your...
Okay.
Okay, those look
I'm so
good.
confused.
Did you get right there? Okay, those look
Yeah.
fine. So let's go to second stat.
Okay.
One of our stats.
Yeah.
So this one should be L1.
Okay. And
That one should be L2, and then that should do it. Yes, you got it. Okay. Yes, other Leslie.
Alright, so whenever I tried typing it in,
Uh-huh.
I couldn't even see
Okay.
wrong here.
So what's up? Syntax error? Is it just frozen?
No.
Oh,
There.
okay. I'm sorry. I just cleared it. Are you trying to do it with the table? I would try with the table because I think it'll help you get it faster. Okay, so now, is everybody good on the standard deviation? Now here's the thing, guys, and here's where tomorrow, just want you to be careful, right? If this was the quiz, I'm guessing 75% of you would stop here. But here's the deal. That's the standard deviation for 1 day. And we need the standard deviation for 5 days. Now, do you remember when Edgar, boys, do you remember when Edgar asked about, do you need the x, like all that stuff, right? Now you're going to see why it's important. Because I really want the standard deviation for 5 days. Right? And the way I have to do this is I have to be thinking variances add. Okay? So what you first would do is you're going to find whatever 1.26 is squared, because that's the variance, and you're going to add that 5 times. You could. Just be careful, right? I mean, you do whatever you feel like you want to do, but I'm just saying you got to be careful when you're doing this. Okay, so let's find out what that number is. What's 1.26 squared? That is 1.5876, and then yes, there's 5 of them. So you could multiply that by 5. What is it? 7.938? Okay, now is that the answer? No, that's squared lights, Catherine, because we just squared everything. So you got to take the square root of that. No, I'm sure I'll get less subscribers tomorrow. Sad. So the answer is 2.82 lights. Okay, so just be aware of that. Tomorrow, you know I'm going to ask about it in some way, maybe not in this way, but you need to be thinking about variances add. So, question? No question. Okay. All right. Any questions on the problem number 1? All right. Let's look at problem number 2 together. I'm not sure if everyone had a chance to look at it. But number 2 is a multiple choice question, and tomorrow's quiz is going to have a multiple choice question. All right, just for fun. Okay, so we've got science majors and English majors, and it wants us to find the mean difference and standard deviation between the amounts that they pay for books between the 2 majors. So the key word I see is difference. All right, so to find the difference in the expected value, I'm going to find the difference between science minus English. Okay, so how much money do I expect science majors to spend per year on books? $650. What about English majors? Excellent. So what is $650 minus $465? Excellent. So immediately I'm crossing out A and E. Hopefully you see why I crossed out A and E, because they have the wrong expected value. Everybody good so far?
Yes.
Now here's where you're going to get students that know what they're doing and students that don't. To do the standard deviation for the difference in the amount of money that science majors pay and English majors pay, you have to again think variances add. Okay? So what's the standard deviation for the science majors? 130. So I'm going to write down 130 squared to get the variance. Now what about the standard deviation for the English majors? 90. And I'm going to write down 90 squared. And what am I doing with those variances? I'm adding them. But you see how that can be confusing?
Yeah.
Because I'm finding the standard deviation for the difference. That's subtraction. But doesn't matter. Variances will always add. Okay? So what is 130 squared plus 90 squared? What is all that? 130. Oh my gosh. This is amazing. So much money. 25,000. Well, remember, that's squared dollars. Do I want squared dollars? No. I want the square root of that. I don't want squared dollars. I want dollars, which is $158.11, which is C. Okay. Now, I'll get a lot of students on this question that will pick D. Why do you think they pick D? They added, which is right, but they added standard deviations. And remember, right, on this bicep, it doesn't say standard deviations add. It says variance. What you're laughing? It says variances add. Variances add, right? Every time. Variances add every time. Okay?
I'm gonna do that. I'm gonna get a tattoo.
Okay. I mean, if you're an adult, you can, right?
It's a meaningful tattoo.
I'm gonna get
It helps every year around Christmas. Okay. Everybody good? Any questions on this? All right. So what? Take out your